All right, last time we were talking about the instantaneous rate of change of a function. We did this example here. This is the function f of x equal x squared. The instantaneous rate of change at the point x equals 3. You do this thing. This was the formula you use. You plug that point in there, and then you do a whole bunch of stuff. There's actually a lot of steps in here. Go back and refresh your memory if you've forgotten by now. Anyway, we got 6 as the answer. At this point 3, the slope here, that's the same thing, right? The instantaneous rate of change, the same as the slope of the graph, is 6 here, the slope, okay? What about if I ask you to do a different point? Instead of 3, you use 4, all right? You go through the same process. The steps are more or less the same. All the numbers will be different, but you do the same sorts of stuff. It turns out, you could work this out if you like, it turns out the answer is 8 in that case, all right? So if you use the point 3, you get 6. If you use 4, you get 8. What about other points? Really kind of the holy grail sort of a question is, you know, can you see the pattern here? When you use 3, you get 6. When you use 4, you get 8. That's just for this function, x squared. But the big question is, what is the slope or the instantaneous rate of change? They're the same. At x, if I don't tell you what the x is, but I want to know, if I give you any x, can you tell me what the slope will be at that point for this particular function? And actually, it's not so hard to figure out what the pattern is here. For 3, you get 6. For 4, you get 8. Generally speaking, for this function, it turns out, for reasons which are not entirely clear, but you always get 2 times the point that you put in. All right. So in this example, for this function, let me just remind ourselves. For this function, the slope is 2x, all right? In this case, the slope is 2x. There's actually a name for this function. You start with the first function is x squared. This other function is called the derivative. Okay, the derivative, the idea is you start with some ordinary function, the derivative of your first function. So the derivative of f of x is another function telling the slope of f of x at each point. All right, and it's written like this: f of x with that little apostrophe there. That's called f prime of x. That means the derivative of a function. So in the example we were just talking about, for f of x equal x squared, we decided f prime of x is equal to 2 times x, right? If you have x squared as your first function, the slopes of that curve is actually equal to 2 times x. Now, how could you actually find the derivative? We didn't actually compute this before. We just looked at the pattern and said, probably it's going to be 2x. But let's have an actual, technical definition. What I just said before, you could say that's a definition, but it's not very useful. I wanted like an actual formula that you can just sort of plug in to get you started. So let's turn this little thing into a definition. The derivative of f of x is, this is a formula for the derivative. What it's going to look like is just the same as the formula for the instantaneous rate of change, only you never plug a specific point in. You just leave the point as x. So what it is f prime of x equals limit h goes to 0, f of x plus h minus f of x divided by h. All right, so this right here, the instantaneous rate of change, it used to have an a here, meaning you're going to plug a specific number in. But in this case, we're not going to plug any number in. You're going to leave it as an x, and the x will just appear in the answer. So this thing right here, you're going to have to memorize. It's very important. When you're doing the actual problems, you leave the x as a variable, and it just is going to pop out in the answer. So let's actually do this for f of x equal x squared. Remember, the answer is supposed to be 2x. All right, you ready here? I'm going to start with, so here's my example, okay? For f of x equal x squared, find f prime of x. All right, it's going to be a little long-winded. It's definitely not going to fit down here. But let's get it started. You begin with this definition. Lim h goes to 0, f of x plus h minus f of x divided by h. Okay, that's the definition. Now you should begin by plugging some stuff in. You can't plug in any value for the x, but you can plug into the function. All right, for instance, what is f of x? It's x squared. So that's going to be x squared right there. So f of x is going to be x squared. What about this? F of x plus h. Again, this is a step which a lot of people tend to screw up. You have to do the squaring, right? What is the function? Whatever goes inside the function, it gets squared. So f of x plus h, you replace the x by x plus h in the function definition, and you get x plus h squared, like so. Remember these parentheses? You parentheses haters? You got to have them in there, or you're not going to do it right. And then divided by h. All right. Okay, let's keep going. You got to do some stuff here, cancel some things out, etc., and eventually take the limit as h goes to 0. Okay, what can you do with this? Well, I think the first thing to do is to expand this x plus h by doing the FOIL thing. So it's going to be x plus h times x plus h, right? And you do the first part. I'll just write what it is up here. All right, the first two guys give you x squared. On the inside, hx. On the outside, also x times h, right? So that's plus 2x times h. And on the end, h times h is h squared. And then, so that was just this guy right here. Now we go minus x squared. On the bottom, h is h. Don't do anything with that. Okay, that's the first step. What are you going to do here? You look up at the top and see, can you cancel anything out? I think you can. You got x squared and a minus x squared. So those guys can cancel. So you get, ignore that, you get, then h goes to 0. Okay, what's left? 2xh plus h squared over h, like that. Okay, what can you do with that? Well, everything on the top has a factor of h in it, so let's pull the h out. H times 2x plus h. That's what you have left over when you factor the h out, divided by h. Why did I do that? It's because I'm going to cancel the h's, right? So cancel, cancel. Limit h goes to 0. 2x plus h is all that's left, right? I cancel the whole denominator of the fraction. And now how do you do the limit here? When you take the limit, you just plug in h equals 0. And what you get 2x plus 0, which is 2x. How about that? That's what I said it should be, right? The derivative of x squared turns out to be 2x. There you go. Let's just try one more. You know, these are a little long-winded. There's actually, I don't know if it looks easy when I do it, but there's actually a lot of opportunity in here to mess it up. But this is how you do it. Let's just try one more, and that'll do it. All right, here's a harder one. Okay, for f of x equal 2x squared minus x plus 1, find f of x, f prime of x, find the derivative. All right, this is, you know, similar but harder. The equation is quite a bit more complicated. Let's do it the same way. All right, so you begin with the definition. F prime of x is lim h goes to 0, f of x plus h minus f of x divided by h. All right, you got to remember this, of course. Okay, first step, you plug in for the function. All right, this is where actually it's going to be a little big and nasty. I'll put it down here. What about f of x plus h? Well, that means you go up to the equation for f of x, and wherever you see x, you replace by x plus h. That's what f of x plus h means. It means you go up here and you plug in x plus h instead of x. So it's going to be 2 x plus h squared. Make sure you got those parentheses in the right spot. Minus, plugging in x plus h instead of x. Here you need these parentheses when you plug in. It matters because of the minus sign here. You're going to have to distribute the minus sign in the next step. Parentheses haters might screw that up. Plus 1. All right, all of this I plugged in here. All right, that was all f of x plus h. Now I go minus f of x, which is that exactly as written. Again, you're going to need parentheses here because the minus sign is going to have to distribute. But it looks like this. All right, and then divided by h. Okay, so this whole first part here is f of x plus h. And then I have minus f of x is that, and then the h. Okay? As usual, now is a matter of just expanding things and canceling things. So the first thing you can do is right here, you can do the FOIL to multiply out the x plus h squared. So it's going to be limit, okay, 2, and now I'm going to do the FOIL in here. It's exactly like the one we did in the previous problem. Oops, x squared plus 2xh plus h squared. Okay, now minus, here I'm going to distribute the minus sign. Minus x minus h plus 1. And then here I'm going to distribute the minus sign. Minus 2x squared plus x minus 1. All right. All of this over h. One more thing you can do upstairs is to distribute the 2 here before you start trying to cross everything out. So let's do that. H goes to 0. Okay, distribute the 2. 2x squared plus 4xh plus 2h squared minus x minus h plus 1 minus 2x squared plus x minus 1. Okay, that's as nasty as this is going to get. From now on, we're going to be canceling stuff out and simplifying, all right? But you got to expand it all the way and then try and recombine all of your terms. Okay, so you look at this and ask yourself, what can I cancel here? Well, I think 2x squared and negative 2x squared will cancel, right? Get rid of those guys. What else? 4xh doesn't really cancel anything. Neither does the 2h squared. I got a minus x here and a plus x here. Those will cancel. I got this h, nothing. Plus 1 and minus 1. Those will cancel. Okay? So what's left over? We'll continue up here. What's left over is... limit h goes to 0. Okay, 4xh plus 2h squared minus h, and that's it, over h. All right, this is looking pretty good. What should we do now? We're going to do what we did at the end, at the last step in all the examples that we do with these kinds of problems, and that is you factor the h out of the top. Isn't it nice that everything which remains in the top has a h on it? If you get to this point in the problem and you do not have h in every term in the top, you probably did something wrong. We're going to factor out the h, so it becomes h. And then what's left over when you pull h out of each of these? 4x here plus 2h here minus 1, right? Divided by h. As always, we end the problem by canceling the h's and then taking the limit. So you cancel the h's, what remains is this. Now you take the limit by plugging h equals 0, and you get 4x plus 2 times 0 minus 1. That's just 0, so the answer is 4x minus 1. There you go. That's the derivative of that crazy function 2x squared minus x plus 1. Was that it? Yeah, 2x squared minus x plus 1. Here's a little follow-up that's very easy once you've done the rest of it. Find the slope of the tangent line to that function, 2x squared minus x, plus 1 at the point x equals 5. What does all of this have to do with the slope of the tangent line? Well, the derivative is the slope of the tangent line. It is the instantaneous rate of change, which is the same as the slope of the tangent line. So how do you do this? All you have to do is you plug in 5 to the derivative. So that slope is actually equal to f prime of 5, right? The derivative, but you plug in 5. Because the derivative tells you what is the slope at each point. I don't know what is the slope at 5. You just plug in the slope. Plug in 5 to the derivative function. And the derivative function is 4x plus 1. So this is equal to 4 times 5 minus 1. I said plus 1. I should have said minus 1. That is 20 minus 1 is 19. There you go. So this function's slope is 19 at that point. Once you find the derivative, it's easy to find the slope at any point. You just plug the number into whatever you discovered the derivative was. All right? That'll do it.